Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. Let's see if I can get my volumes set here. Let's bring the bar up just a little bit here. Let's make sure I'm not going into some massive clipping. All right, so today we are going to be working on what is this? A Hifonics HFI1000.1D amplifier. That is in, of course, for repair. Well, every amp that comes in is for repair. Not really. There I do get some that are in for service. And this is just one of those amplifiers that some people tend to have a problem with understanding the drive itself. And this amplifier is a prime candidate for a video on rebuilding this particular type of amplifier. Now, you have to excuse me, my voltmeter is not hooked up to the computer. I'm having some technical issues when all my equipment's hooked up and running on screen, then I start to have weird glitches. Let's see here. So the very first thing I'm going to do is I'm going to pull all the screws out. Let's make it to where I can remove this board, because I already know that this board has to come out because there are, looks like power supply transistors right here. Got a little hot. Well, technically it failed. Excuse my bald head in the camera there for you guys. I don't have a lot of room in front of me, otherwise I would just have my camera facing me, but I've got about 2.5 feet to the wall, so a little too close for the camera as I just ramble on while I take my screws out. And yes, I do use a Torx bit screwdriver to take out Allen screws. Why? It works. I'd rather have one screwdriver to do 2 tasks than 2 screwdrivers to do 2 tasks. So, for anyone that does this as a business, you already know that you wear out tools very, very easily doing this kind of work, especially 6 days a week. And you'll hear my dogs snoring in the background. They let me know when someone's coming. So let's get these screws on out of here. Looks like my exposure might be a little high. Is that what that is? The exposure or white balance? Let me see if I can tame that down a little bit. Where is that? Exposure? Is that what it's called? Exposure. Is that a little bit better? It's a little bit better. I didn't want to blind you guys. I have a crazy amount of light above me. Just a little fun fact for all you people that see me just as a amplifier repair person. Right up here on this shelf right here, I grow carnivorous plants. So I think I've mentioned that in the past. So I have a bunch of light above me to keep my plants happy. Happy plants, happy me. So let's see here. Good old Hifonics plastic there for you. I like Hifonics. I mean, as a company, they don't bother me. They pretty much leave me alone. They do send me They do send me customers that are in need of Hifonics repair. I initially first contacted Maxonics, which is the parent company, back in 2019, and I've been just kind of talking with them ever since. Dirty. Sampa's dirty. But yeah, they have released amplifiers that utilize many different styles of different topologies of amplifiers. So Hifonics is a great brand all around to start learning the different topologies of amplifiers, because they've used almost all of them. Almost. I could be wrong. They may have used all the topologies. Like on their newer amps, their topology is really similar to the Orion amplifier that uses the 2110 drive IC, which I think they did that in 2020 or something like that, and I even gave them good thumbs up. Good job there, Maxonics, for doing that. So I believe it's a much better drive than some of the drives that are available on the market right now. It looks like this amplifier may have gotten wet. I see some indications of rust. When you see rust, you have water. Now the last board for this customer that I did, when I took the board out and flipped it over, it had a big hole in the middle of it, so I couldn't repair it. I could, but it would have cost a lot of money for him to repair that amplifier. Now we just got to get all these transistors off of the thermal pad. And I just grab the top edge of the transistor and just pull it back. Now right off the bat, I see something interesting on this. You guys can't see, it's on the back side here, but this row of transistors right here are 640Ns, but we have two different styles. I don't think I've ever seen a 640 with the clipped top edges of a TO220 transistor. I'm not so sure about that. Even the ones that are in like the cab boards, they're not the trimmed edge. They're always the square edge. The square edge. So we'll see when we pull them out. Piece of transistor. All right, let's get this thing out if I can, unless I missed something. You never know with these boards where they're hiding a screw. Oh, I found another one. Hiding? Why? Because it's black, because they covered it in that glue. There we are. There it is. All right. Of course, we have an LED. Yeah, you know, can't go wrong with the LEDs. Ditch the heatsink. Put it on today's deliveries. Let's see here. Oh yeah, failed power supply. So now let's see what we got going on with this board. The next question is what do we have to do with this? That was the next thing I always look for. What's wrong with it? What do I got to do to fix this board? Let me get you guys some meter action. And yes, you guys know it. I am on resistance. I'm just different. Let's see here. What do we got? We know we have a blown power supply. Obvious. I don't even have to measure that. Obvious. Well, there we go. Blew the top right off of it. Oh. That's interesting. Huh. Okay. Yeah, blew the top right off that transistor. I was going to say, if this has ever been replaced, that possibly could be a fake 3205. Wait, are these the 3205s? I know, assuming is bad. As a retired electrician, I was always taught, don't ever assume. Assuming can get someone hurt really bad. Oh, these are the IRZ 44s. Ha, funny. They're not going to be when I'm done. So, we know there's a short there. Given. That's a dead given. So let's come check the output section here. You're going to have a high side and a low side. 20.5 ohms. Well, we know that's wrong. Why is that wrong? Because you should... We have, what, 100 ohm? Well, we're not going to know because we are shorted. So 20 ohms. Oh, 0.01. That one there's got the lowest reading so far. 20 ohms. 22 ohms. 22 ohms. 2.1 ohms. So you have two resistors here that are significantly less than the others. I'll bet money if I cut these two out of here, you're going to see a different number here. Thermal paste. It's Monday morning. I don't want to get thermal paste all over me. Garbage can. Garbage can. All right, let's see. Did this, what I call, free up the circuit? Oh, well, looky there. 33K, 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 33K. So, why is 33K such an important number? I'm going to try to help explain that to you right now. We have 3 transistors on the high side. We have 3 transistors on the low side. Each transistor has a gate resistor. Each transistor has a pull-down resistor. Each pull-down resistor is in parallel to that particular set. So we have a set of 3 high, set of 3 low. And let's see here, these are probably 100K pull-down resistors. I'd have to lift one. Brown, black, let's see here. Let's figure this out. Brown, black, yellow. Let's come over here to my good old turntable here. Brown, black, yellow. Just as I expected. No, I don't have color charts memorized. No. Way too much to try to remember. This poor old man's brain can't fit it all. But that is what you have, is brown, black, yellow. So you have a 100K resistor pull down for each transistor. 3 in parallel. 3 high, 3 low. So 3 100K resistors in parallel will give you what? Will give you roughly 33.18K. It's Ohm's law. So you have 3 100K resistors in parallel, and that's what you're reading here. So I'm always looking for one of two things, either your gate resistance or your pull down resistance. If you know you have 4 100K pull down resistors, you're going to have 25K per transistor, and if you're reading 30 ohms across the gate and source, it's shorted. There's a short. That's why I use resistance. I have a given value. I look for the value and go from there. Now I could have used forward voltage diode mode, but which will show you some, junctions leaking or whatnot. But you would not believe how many techs don't know that transistors can leak. So that's a little transistor 101 for you. But the resistance values tell me everything. So the rest of these are good. It lost 2 transistors, 1 on each bank. So from there, we just cut everything out. Pull the legs, replace the components on the power supply, leaving the output still out. There's a reason for that, and we'll get back to that here in just a minute. I'm going to remove all the shorted transistors. I'm going to get my transistor remover tool. I'm kidding, guys. It's not a transistor removal tool. It's what I use to cut transistors out. The quick and easy way. That's how you cut a transistor out. And then what I do is I just use the Hacko, the FR301. I heat the V up, pull the leg out, hit it with the desoldering gun, and it's ready for the new transistor to go in. Quick and easy. Excuse me. As I pick up transistors. I'm too busy to waste time. So if I were to sit here and take my desoldering gun and desolder each pin to pull the whole transistor out as a whole, it's kind of pointless when you know you're going to be replacing them. It's much easier to cut the transistor out, heat the leg, pull the leg, hit it with the desoldering gun. Done. I guarantee you I can have that site clear in just a fraction of the time versus someone that's trying to desolder each pin and pull the transistor out as a whole and clear the vias. I see some really, time-consuming stuff that happens in the repair world. But yeah, from there, I'm going to go ahead and pull these legs, and I'm going to remove these transistors too, and these legs, because we're going to check the drive first. So I'll be right back with you guys. All right, guys. I'm back with you. Just to let you know that the original 640 that came out of here that were shorted are the ST IRF 640s, which is odd. I don't think I have seen that before. I could be wrong, obviously. But I just wanted to, as I was saying earlier, it's easier to cut the transistor and pull the leg after you cut the transistor out. And I figured I'd just show you how I do this. Right down here below me, you can see I have a garbage can. Pretty much right directly below the board. So I'll just... And this is pretty much how I do all amplifiers. Of course, it does help to have a properly maintained desoldering tool to help keep to help maintain the sanity of desoldering, 60 transistors out of a board, which I do have videos out explaining the tear down and maintenance of the FR301, the Hacko FR301. It's kind of my go-to desoldering tool. I do have the 808, which is my big boy that is set at a much higher temperature, which I use for terminals in really large trace areas. So you have enough heat on the via to desolder it when the leg slides out. I'll get boards in where people have removed something from the PCB, but they use so much heat that it destroys the via. My 301 here is set at a 2. Well, just a hair under 2, and about 1 3/4. So I do not use the highest setting. I use whatever setting is necessary to melt the solder without applying additional heat to the surrounding area. And this is just, me just give an example of a easy way to desolder your components that you know you're going to be replacing. There's no need to fight it. There's no need to use 800 degrees Fahrenheit, or whatever it may be in Celsius. There, I just cleared the output section and the power supply section. Excuse me. I always remove this from the desoldering gun after I use it every time. Why? Well, you leave this thing in that tool and you leave it on, you're gonna melt this, and it'll start to become real flush and flat, and at some point you're not going to make a good seal against the 301. But if you take this out after you use it, just as a habit, I just squeeze the trigger and it falls out. As a habit, the end of these will last a lot longer. But of course you can get replacements from Hako, which I do believe I had shown in a previous video. Of the parts that you can get directly from, Hako to rebuild your FR301. And I carry all the numbers and all the part numbers. So as you can see, I carry extra ends direct from Hako. So again, when you run a business, you have to look ahead. If you have a tool failure, you got to be able to continue and move on. So I always have something. If something fails, I have a backup. All right, so we got power supply out, output section out. I'm not even concerned about what the output's doing right now at all. It's not even in my mind, because this amp will start without the output transistors as long as the protection circuits allow it to. You could have a fault in the overcurrent protection circuit and it'll shut the power supply card down. 9 times out of 10 though, if you just pull your output transistors, you should be able to fire your board up. So I'm just taking some isopropyl alcohol, 70%. It's got a little bit more water in it than the isopropanol. So it does help. It cleans the board, but not as harshly. So you see my camera up there? Equipment guys, I love it. But yeah, I use the 70% to do a majority of the cleaning part of the board. I gotta be able to see what I need to do. Right now, my primary objective is to get the power supply running. So what I'm going to do at this point, I'm going to take a reading of the gate resistors here. So, these are 44s. I was going to say, that's odd, because see that camera? Oh, there we go. Oh, it's because of my bald head. The IRC44, I don't believe is big enough for when there's a short that it burns out a, what is that, a 1/4 watt carbon resistor. Now, if this was a 3205, it probably most likely could have taken out the gate resistors. My blinds are closed, and so I can't hear when UPS and FedEx and DHL shows up, which they show up every day. Let's see here. What am I doing? Gate resistors, 47 ohms. Oh, I'm assuming. No, I'm 47 ohms, so typical. 46, yeah, none of these are going to be shorted. 46. The IRZ44 is a good transistor. It's an old transistor, but it's not the tallest transistor on the block. So we have good gate resistors. I'm going to make sure that I have cleared the short. Oh, I'm sorry, guys. Before I had a 67 ohm short across the power terminals, but I had an obvious blown transistor, so I knew it was already shorted. But let's see, we should show capacitors charging. Let me show that again. Some people are also confused about, oh, I'm shorting out the positive and negative, just to let you know. I have a pair of tweezers here, old tweezers that I used to short out my positive and negative. These capacitors right here charge. So let me do that again. Watch the meter, guys. See how that meter, actually, let me try that again. What we were doing is we were charging, well, nothing, because the fuse is out. Ready? Here we go. All right, there it is. See that meter climb and climb and climb and climb and climb and climb. It's charging the 12-volt filter capacitors. And it'll continue to climb. And at this point, I could have stopped measuring a long time ago. If there would have been a short, this would not move. It would show you a resistance value and stay there. Capacitors will show a short when discharged. Short, right off the bat. Bah. Oh, nope, because in order to discharge this, I either have to put a fuse in. Blah. Okay, hold on, guys. Never fear, I've got you covered. Let me dig back in my drawer here, way back in here. There should be some, okay, maybe not so far. There should be some fuses. Let me put a fuse in. Test fuse. This is a test fuse. This is not going to stay in the amplifier. This is 120 amp fuse. Would I do 120 amps on this? Probably not. I would probably do about 80 amps, probably 80 to 100 amps. So I'm just going to take my fuse and attempt to. There it is. Now I can discharge the filter capacitors the easy way. So there it is. You saw 6 ohms there for a second. Capacitors are short when discharged. So I have a lot of inrush current when you first hook up a really big amp. Which doesn't matter. The inrush current doesn't hurt anything unless you're using a really small wire and you have a lot of inrush current and it burns the wire up. The amp doesn't care. These capacitors don't care. It's going to take whatever it needs from here to charge. Input inrush or input inrush from your power supply will not damage the output. It's isolated. It's isolated. So if it did damage the output, you have a problem with the power supply, or you have a problem with the amplifier. Inrush current will not damage your output. So this is ready to start. Gate resistors are good. I don't see any damaged, popped drivers, but you know, 2 transistors were cooked. So the drivers are probably going to have to be replaced. Well, they should be replaced. I'm just checking to make sure this trace is okay. There's a trace that comes off the source here. Comes right around and looks like it goes over to... well, I can already tell you guys. I can already tell you what happened here. It's quite interesting. So the source of this transistor, this trace got really, really hot right here. Really hot. But if you follow this trace, it goes back to the jack. How many amplifier failures have you seen where they have plugged in a bass control knob and shorts the preamp out? Well, you got to have power to it, but most times they don't take power from the power supply. I don't know, just an observation. So let's give this some power and see if I have a functional power supply. Yeah, my scope is not on the screen. Probes got tangled there. Because if I turn my scope on the screen, this image is going to start to glitch. Yeah, we'll leave it at that. So power, we have power, we have power. All right, what are we at? 20 volts? No, way too high. Your gate drive, if you set your scope to about 5 volts, you're about right to inspect your gate drive. Now, I should get a green, no, I won't get any light. Depends on where they reference the green LED from. Oh, how funny is that? That's pretty funny. So, a lot of amps will reference the green LED to your rail voltage. Going through another IC. So when you have rail voltage, the green LED comes on because that really is telling you that, hey, you do have a functioning amplifier. This green LED is actually driven off your power supply card. So if this green LED is on and there's no amplifier function, blame the designer. But right now the green LED is on and there's no rail voltage. I don't even know if we have square wave at the drive. So usually this comparator on the power supply drive card here runs the red LED, your protection LED. So they're grabbing this green LED from something else off of your probably the relay circuit. No, because the green light comes on before the relay. So it's coming on off of something over here at the power supply. It has nothing, this green LED has nothing to do with rail voltage. Well, let's see if we have drive as I ramble on. Oh yes, we do. Clean square wave as can be. Clean square wave as can be. Not even a glitch. What are we at? 27.8 kilohertz. Right on the money. You can't complain about that. 47 ohm gate resistors. So the power supply, I do believe, well, we had 2 shorted output transistors. So it probably wasn't due to an external. Nah, it was due. I'm gonna we have a bad drive. We'll get to that. I'm just thinking ahead. You always got to think ahead when doing this kind of stuff. So we have drive, which is good. The driver. So the power supplies didn't have a massive drain source short. either the customer's car didn't have a lot of ampacity, the circuit, I mean, there's a lot of reasons why, but when this failed, it didn't create such a surge that it destroyed everything behind the transistors. So we're going to go ahead and put some 3205s in. Drawers full of them. 3205s, we'll fire up the power supply and see what we got over here. I will be right back with you guys. All right, let's get these transistors in place. So I've got my 6 3205s here, of course, matched. You're gonna have 3 and 3 for your parallel sets. Pretty crazy. 3 and 3. 1 transformer, 3 transistors per half of your primary. It's kind of some people kind of have a hard time grasping how this really works. Let me try to get you right over this board without blinding you from all the lights. Okay, so let's just do a quick transformer 101 here. As I said, you have 3 transistors. There's your transformer. This is your primary side. How do I know it's the primary side? Because here's your capacitors that filter the 12 volts. Primary side. Secondary side. Oh, upside down. Sorry guys, I can't write upside down. So you have 3 transistors in parallel that drive this coil and 3 transistors in parallel that drive this coil. So when this 3 is on, this 3 is off. When this 3 is off, this 3 is on. It's on, off, on, off, on, off. All it's doing is taking 1/2 of each side of the transformer. On, off, on, off, on, off, on, off. It's just swinging that signal. They use the term push-pull. I don't like that term because we're really not pulling anything here, but the transistors are being pulled back to ground. I mean, it's kind of, the word push-pull is kind of, in my opinion, the wrong word to use. I don't know. On and off is what I would call it. Yeah, can never have both of them on at the same time. Transistors get really hot when you do. So let me back it back up here. Because what I'm going to do is I am going to solder the transistors in place. It's really, really simple. I start off with the transistor, putting them in with my left hand, so the furthest right over. Really what I'm doing is I'm just getting the transistors in place, somewhat straight. I'm very particular on transistor placement, how they're placed. Sometimes, like on the cab boards that come in with no heatsink, you got to kind of guess. But I always leave the legs available for them if they need to adjust the transistors, which they just end up bending the legs. All right, so I got all the transistors temporarily in place. What I'm going to do is I'm going to match the height to my neighboring transistors. You can see the 6 I just put in, and I'm just going to bend them down just a little bit, so we are a little high. And I'm going to adjust the transistor to be the same height. Perfect. And then what I do from there is I just match the rest of the transistors to that height. And then once I verify that the height is correct and that I'm completely happy with how it's placed out, I will solder in the rest of the transistor legs, making sure that the transistors are straight to reduce any potential problems at the heatsink. And then I just go through and solder the rest of the legs, paying attention to not cause any solder bridges. It does happen more than you think. I've caught myself many times taking care of solder bridges because sometimes these things, the traces can be pretty close. A little bit of flux here and there. I'm using a solder that's a little higher in tin. It's got a little higher melting point, but it does require a little bit of flux because of that high tin content. But this Amtech flux just really flows this solder nicely. It's all about finding what works for you. And then I double check, make sure I didn't forget any legs. Because I've done that before too. You get tired, you're moving right along your transistors and you forget to solder a leg. Well, I wouldn't power it up. If you had a solder leg that was, oh, I got my camera crooked. Sorry guys. The transistor will pop on you if you forget a leg. It depends on what leg you forget, especially if you forget a gate. So there's the power supply transistors there. Let me make sure that we're nice and the right height. We might be a little high still, but that's okay for right now. Oh no, that's not too high. Yeah, not a lot of room there in that heatsink, that's for sure. All right. Well, from here, what we got to do is just power it back up again. Now this will build rail voltage, so I have to watch for temperature. This is just something I do on every amplifier when I'm going to go charge up the rail capacitors. Even on these small amps, I don't want to have to fix more than I have to. So a thermal imager will show you really quick what's heating up. Make sure I don't have anything that's previously hot, which these are a little warm. I can see that because I just got done soldering these. But these will glow red hot if there's an issue. So as of right now, I don't believe there's going to be an issue, a problem. It would help if I turn the power on. So let's see what this thing does. Yeah, fires right up. Card gets hot like it should. These cards run absolutely hot. And we're gonna get to that output card here soon. Nothing was heating up. And that's That's how quick the test is. It'll heat up that quick if there's a short. Especially on a rail cap, if you have like a negative rail capacitor, it'll heat up on you if there's a short in the capacitor. Any transistor will heat up instantly, but all the temperatures looked normal. The next thing I'm going to look for is, what is this output card doing? So we do get a relay. We have a green light. We already know the green light has nothing to do with rail voltage, so we're going to just ignore the green light. It's pointless. Let's see what we got for drive. Oh, well, looky. Ooh, yeah, not so much there. Yeah. Ooh. So, all right, turn that off. With these cards, you should have a drive at negative rail and a drive at positive rail. With these cards, maybe not. Hold on. Are they running a positive rail? Yes, they are. Okay. Yeah. All right. Negative. Yeah. Positive. All right. So let me get the scope set up for you guys, and I will show you what we should see on the output drive of these cards. So I will be right back with you. All right, guys, I have the oscilloscope up and running, so you'll have to excuse the picture when it decides to do its thing. It will have a couple glitchy spots in it. But I wanted to show you what the output drive is doing. So you should have a low side square wave drive, and you should have a high side square wave drive. So let's go ahead and power this thing up. Well, look at that. Look at that mess. So that is supposed to be your high side square wave, and here's your low side. So there's your low side square wave. So we do have a high side drive issue, because it should be referenced to the positive rail. Or am I wrong? Let's find out. All right, so you guys are just gonna catch me here just finishing rebuilding a card. Well, not really rebuilding. This card here is a backup card that was missing a resistor. Looked like it got knocked off, so that's probably the reason why this card didn't work. We're just gonna find out. I'm gonna desolder this card. Oh, another tip of the day on your desoldering guns. Back there, that little metal thing back there that catches your solder. I give it a really brief spray with that. Great stuff. I've been using that for years and years and years. I don't even know if you can get it anymore. I just quickly put just a little spray of oil on that. Your solder slugs fall right out. Tip of the day for the Haco FR301 and other desoldering guns. Always looking for a way to make the job easier. How many of you guys have fought to dig the solder off that thing? Well, give it just a little bit of oil and your solder slug will fall right out. Oh, someone's had this card out before. Pretty obvious. Because that is not lead-free solder that's on it. These grounds can get a little hairy. Gotta get a little hotter than that. There we go. So I'm just going to take this card. We're going to pull this card out. Could I have a bad driver? Absolutely. Absolutely. But, hold on. But as I have mentioned, these cards run extremely hot. That's the number one problem with these, is they do like to fail from running so hot. I've got me some... Come on. You can do it. There they are. There you are. I knew I got that. All right. Of course, take this out so I don't deform the top too bad over time. Pull that out. Put it in. And solder it back in place. Then I'll just use my normal Kester 6040 solder on the drive card itself. I'll use the high tin solder for the larger transistors, larger traces, higher current areas that get a little hotter. So that card is in. Now this is going to tell me whether it's the drive card or I have a bad driver. The one thing I do like about Maxonics here is that they used some transistors to drive the output transistors. Let's see what that card does now, if it doesn't blow up in my face here. Just like the other one. So what we're going to do is we are going to replace. Now we are going to put in some 6. I'm thinking this does not drive the high side. So if it, oh, actually it can. What am I thinking? They're 640 ends, so they're N-channel transistors. If it was 640s and 9640s, then you would have a high side drive. So, hold on. I had to find where I put them. I had 6 transistors when I was doing inventory that were matched out of any other transistor I had. I got a bunch of 640s, but they're not matched to these. And I just happen to have 6 of them. All right, so what I'm going to do is I'm going to install those 6 transistors, because I do believe, since they are N-channel transistors, that this drive right here may be correct. Maybe. Yeah, I'm not sure. We're going to find out. Rails. What's rule of thumb? I don't ever install transistors on rails that can be charged. So I'm just going to do a little dance here. Whoops, at the rectifiers, if I can get the right ones here. Good. Just make sure my rails are discharged. I would not install transistors on rails that are charged. It's just a little FYI. We're going to do the same thing. We're going to flip it over. Start from the right hand side and work my way over because I install the transistors with my left hand. The IRF640 ends. Extremely common transistor to use. And then I'm going to place these about the same height as the power supply side. Let me get my high tin solder ready. And I'm just going to solder one leg for now. If you solder all three and you have to make an adjustment, it really does make it a lot more tedious to adjust the height of your transistor if you solder all three legs in. So what I do is I just do one, and I'm looking at the edge of the board to see when I install it that it's parallel with the face edge of the transistor. So that's what I'm looking at when I'm sliding them in, is I get the right proper height of the transistor. And then I match up the two edges, which will maintain the proper height. There's my dog snoring again in the background there for you. It does help maintain the proper height of the transistor if you're not sitting square in front of it. So let me get this last one in here real quick. And then I'm going to make sure they're straight and of course at the right height. Perfect. Make sure they're straight. Gorgeous. And now I'm just going to solder the rest. Again, making sure I don't cause any solder bridges. It's really easy to do on these vias that are so close together. Done. Output transistors. Make sure I don't have any solder bridges. So I take my really fine point tweezer, go right in between the vias here, just to make sure that I can fit this in between. And I think I might have a solder bridge right there. I can tell because my tweezer would not go past in between that. So I'm just going to heat it up just a little bit more. Heat this up a little bit more. See if I can, there we go. Now my tweezer can get in between it. So I know I don't have a short there. And you can also take your meter and you can also check to make sure you don't have shorts. You should still see your pull down value. 32.7, 33.1. Come on. 32.8, 32.8, 32.8. Nice. All right, so we're good to power this back up again. Again, using the thermal imager. Oh, I gotta let these transistors cool down. I'm watching for temperature on these really close. These have to be at the same temperature as everything else. So I'll be right back with you guys as soon as these cool down. All right, let's see here. I've just been kind of blowing on the transistors there. They're a little, oh, you can't quite see it. Oh, a little bit. Try to get you guys a picture of those transistors there. Kind of hard. Sorry, you get a glare of all my lights above me though. But I'm looking for heat before I even use the scope. I want to make sure nothing is running away on me here. Let's power this up. Ooh, relay clicks. Power supply is cool as can be. Output transistors look like they are maintaining. Nice. Looks good. Let's see what the scope is telling us here. There it is. Perfect. Yes. So initially I was wrong. Since it did not have the 9640s in it, we won't see that positive drive. So they're using this is just like a type 4 board. Is how they have this set up. We have a low side drive that drives the high side, kind of like a bootstrapped circuit there. So we do have, let me see if I can get a better view for you guys. So there is your output square wave. And we have no DC offset, so there's nothing there. Perfect. And that's exactly what we're looking for. So the card's good now. This card that came out is actually still good, but I always recommend rebuilding these cards. Why? Because they run so hot. I do have a video out on rebuilding these cards. I could do an updated video, guys, if you wanted to, but it's the same. It's been the same over the years. Replace your P2Ds. Replace the P2D transistors. Let me get right on down here. Replace the not on autofocus. Man, hold on, guys. Let me see if I can get you a little bit better picture here. And we know that the drive is good, so we're just going to turn the scope off so my video quits being glitchy on you. But you want to replace these top. Let's see if we can get this camera to do what I want it to do. All right, there we go. So you go ahead and capture that there picture there for you. So you want to replace the top 3 P2Ds. You want to replace your transistors across the bottom here. You typically don't have to worry about the comparators for the most part, or the op amps, I should say. I think there's a combination between 2 072s here, or even possibly a comparator in 072. So I'm not sure 100%. I have some cards here that aren't defaced, but again, I don't memorize a lot of things. But I do know that the top one here does run significantly warm, but typically I don't have to replace those. It's usually this here, and I will add solder to here to act as a heat sink, and then I'll also add solder back here to add more mass. And that's why they do that, to help just get the heat away from this card, because these cards run extremely hot. So there's that amplifier, all up and running for you guys. Just a simple failed power supply, shorted output section, running 640Ns on the output. Really just a straightforward thing. This is what I do every day, all day, for the most part. So I do thank you guys for watching. If you have any questions, please leave them down below. I will get back to you just as soon as I can, and help answer questions the best I can. A lot of times I just can't answer questions without this being on the bench. I rely on all this equipment to tell me what's going on. So, and of course, knowledge of common failures. So again, guys, just keep your fingers out of the rails. Sometimes these voltages can get significantly high and can be dangerous if you don't understand electricity. So please, if you have any questions, again, down below. Thanks, guys, for watching. Stay safe. We'll catch you on the next one.